Good day, everyone. We are with Group 5 of STEM 11I. With the team, we have Aguilar, Erika Sarabia, Elisha Mordeno, Zyrene Mercado, and yours truly, Pauline Villanueva. Caffeinated beverages cause the human body to produce more adrenaline, making you stay more focused on work. As the pandemic arrived, the online school-related workload continues to increase, as well as the rise of trends such as many different caffeinated beverages to the Generation Z.
The main objective of this research is to unravel the relationship or influence of caffeine consumption on grade 11 STEM senior high school students to their daily productivity. Specifically, the objectives are to identify the most consumed caffeinated drinks and drinking habits among STEM students, to determine the STEM students' daily working hours, including class hours and homework or studying schedule, to determine the STEM students' number of hours of sleep on weekdays, to determine the relationship between the number of caffeinated drinks consumed in a day and the number of working hours and sleep of STEM students, and to distinguish between the correlation of the two variables being corroborated would help to analyze the influence of caffeine consumption on STEM students. Caffeine use has been related to enhanced productivity by improving our mood and energy levels. It also promotes adrenaline production, energizing us by speeding up our heart rate. With this in mind, researchers of the study suggest there is a statistically significant relationship between caffeine consumption and the daily academic performance of STEM senior high school students.
Senior high school academic performance during the pandemic. The pandemic distressed students who had difficulty adjusting to the new normal way of learning. The online distance learning method requires longer screen time and more requirement buildups. In the Philippines, senior high school students have been exposed to this style of academic environment for about 2 years now since March 2020.
Caffeine is a substance with both positive and bad properties. Caffeine is a moderately effective alerting substance. It can potentially improve your reaction times, mood, and mental performance. On the other hand, caffeine has the potential to interrupt sleep. Caffeine, according to studies, can cause the biological clock to be delayed.
This research will only focus on the primary effects of caffeine that affect the condition and performance of the participants. In light of this, the researchers want to see if caffeine helps students finish their tasks faster and if drinking caffeine shortens students' working hours, allowing them to finish tasks more efficiently and sleep longer.
For our methodology, a random sampling of 60 who were grade 11 STEM students of DLSU Manila participated in this study. This study utilizes a quantitative research design through online questionnaire surveys. The standard numerical measures of cup sizes of caffeine intake and daily working hours declared by DepEd will be used as a basis for the questionnaire. Online learning working hours extend to 8 hours a day. This will be automatically included in the calculation in finding the average working hours of students. However, the DepEd mentioned that grade 9 to 12 students should only have a maximum of 4 hours of screen time to do their online submissions after classes. These conclude that the average healthy working hours of senior high school students should be at most 12 working hours. Henceforth, a point estimation, one-tailed test, two-tailed test, and linear regression were used to verify claims from the survey results.
Our first topic will be the estimation of a single mean. The sub-problem question is, what is the average caffeine consumption of DLSU-IS Manila grade 11 STEM students per day? In this case, the average daily caffeine consumption of grade 11 STEM students will be determined and tested. This hypothesis was put to test by analyzing the caffeine consumption of a sample group consisting of 60 students. According to the results of the survey, only 50 students consume caffeine at least once a day. Therefore, 50 students will be the sample size in this case. In regards to the usual sizes of cups of caffeine beverages, the mean was calculated to be 14.4 ounces with a standard deviation of 6.3. To use these results, the researchers will construct an interval estimate using a 95% confidence interval for the mean ounce of all grade 11 STEM students. The given are as follows. Since the sigma is unknown and the sample size is greater than 30, the second condition for confidence interval will be used where sigma is unknown and n is greater than or equal to 30. In finding a 95% confidence interval, the confidence coefficient is 95% or 0.95. We equate this to 1 minus alpha, which gives us alpha over 2 equals 0.025. Z sub alpha over 2 is then C sub 0.025. According to the table, 0.025 is 1.96. Now let us compute the confidence interval using E equals C sub alpha S over square root of n. Next, the lower and upper confidence limits follow, which is 14.4 positive negative 1.75. By subtracting and adding 1.75 from 14.4, the 95% confidence interval will be calculated. Based on the sample size of 50, our best estimate of the true mean ounce of caffeine consumption of grade 11 STEM students is 14.4 ounces. With 95% confidence, we say that the mean ounce of caffeine consumption of grade 11 STEM students is between 12.65 ounces and 16.5 ounces. The margin of error here is larger, primarily due to the small sample size.
Here we address the question, does the average number of working hours of STEM students who consume caffeine exceed 12 hours? Suppose you want to test the hypothesis that the students who drink caffeinated beverages have working hours not beyond healthy screen time of 12 hours. To test this hypothesis, from a sample of 60 students, 50 who have consumed caffeine at least once a day with their corresponding working hours were obtained. The mean of working hours is 13.02 and the standard deviation is 1.67. This automatically constructs the null hypothesis as it's less than or equal to 12 coming from the statement no beyond healthy screen time of 12 hours. For the alternative hypothesis, we have its opposing claim that students who consume caffeine have a screen time or working hours of more than 12 hours. Now we want to use a 0.05 level of significance. This is because it defines a range of values that you can be 95% certain contains the population means. With its z-score, we can set up our decision rule for the test. These are the computations. Thus, we come up with a conclusion given that the z-score exceeds the critical value and the 12 hours is not within the calculated interval, we conclude that the mean of student working hours who consumes caffeine is more than 12 hours.
Test concerning the difference between two means. The significant difference in the average sleeping hours of DLSU-IS Manila grade 11 STEM students who consume caffeine beverages at least once a day and those do not were tested. The hypothesis testing which concerns two means was used. There were a total of 50 students who responded that they consume caffeinated beverages at least once a day, while the remaining 10 confirmed that they do not consume caffeinated beverages. In regards to the first set of 50 respondents who consume caffeinated drinks, the mean was found to be 5.64 hours with a standard deviation of 1.246. As for the second set, there were 10 respondents who did not consume caffeinated drinks, which resulted in a mean of 5.5 hours and a standard deviation of 1.509.
To test the concerned means, case 2 will be used, where samples n greater than or equal to 30 are independent with unknown variances. Suppose that a level of 5% level of significance is used. As for the critical value based on the level of significance, it would be z is equal to 1.96. The null hypothesis, which states that there is no significance between the two means, shall be rejected if the test value is greater than negative 1.96 or less than 1.96. Since the computed value is not within the rejection region, we fail to reject the null hypothesis. Based on the given data, there is not enough evidence to prove that there is a significant difference between the average sleeping hours of DLSU-IS Manila grade 11 STEM students who consume caffeinated beverages at least once a day and those that do not at a 95% confidence level.
Grade 11 STEM students working and sleeping hours. The regressor is denoted as A, response variable B, linear coefficient R, and the sample of coefficient determination R squared are calculated using the individual responses of 50 respondents. Linear regression equation y equals 7.55 minus 0.15. Linear relationships, strength and nature are discovered to be R equals negative 1.81 weak correlation and indirect linear equation. R squared is equals to negative 0.328 or 3.28% is the variation of working hours explained by the sleeping hours of students who consume caffeinated beverages. A significance test is conducted concerning the working hours and sleeping hours of students. With a degree of freedom 48 and the probability of error 0.05, if T is greater than T 0.05, DF48 is equal to 1.6772, HO must be rejected. The computation results to negative 1.53. The decision is not to reject HO since 1.6772 is greater than negative 1.53. There is no significant linear relationship between the working and sleeping hours of DLSU Manila Grade 11 STEM students. Hence, there is no indication that the hours spent working and sleeping by STEM students are related.
Caffeine consumption has been associated with increased productivity by enhancing our mood and energy levels. Caffeine boosts adrenaline synthesis, thereby invigorating us by increasing our heart rate. Due to school-related issues, students' caffeine consumption has increased. But through related literature, gathered data, and assessments, the researchers determined that there is no significant linear link between caffeine consumption and the academic performance of DLSU-IS Manila Grade 11 STEM students. Furthermore, it is evident that caffeine does not affect their sleep and academic performance. However, it is only attributable to school assignments and activities depending on their quantity. That is all for our presentation on the analysis of caffeine consumption and academic performance of DLSU-IS Manila Grade 11 STEM students. Thank you.